So in this video, we're going to talk about rotations. So rotations are another rigid transformation. We are turning our pre-image to create our image. Our pre-image is also going to change its orientation, similar to what we looked at when we looked at reflections. The original orientation of the points on our shape will not be the same after we do our rotation. And the origin in Math 2, our center of rotation is going to be the origin. Thankfully, we don't have to worry about it from other points other than the origin. So what we're going to do first is actually look at how to do these rotations. So I'm going to show you two different ways that you can think about this. So sometimes to help us visualize, we can actually just turn our paper. And the reason we can do this is because the origin is our center of rotation. So since I'm going 90 degrees counterclockwise, I'm going to be moving my picture the opposite way from a clock turning. Another way you could see this is negative 90 degrees. So if they say rotate negative 90, that does also mean rotate 90 degrees clockwise. So if I take my picture and I turn my entire picture 90 degrees counterclockwise, this is what my image should look like when I return my graph to its original orientation. Now, what you can do at this point, since this is where my new image will end up, I can pull the coordinates from this picture right now, and those will be my coordinates for V prime, K prime, W prime, and J prime. And I'm going to do this on a sticky note, just so that when we turn it back the normal way, we can see what we're looking at. So here, if I look at what V prime would now be, yes, this is the y-axis and this is the x-axis when I turn it back the original way. But knowing that this is we're going to pretend that this is quadrant 1, this is what my image should look like. So V is going to land at positive 3, positive 2. K prime will end up at 5, 3. W will be at 4, 5. And J prime will be at 2, 4. So these are my image points based on what this rotation should look like. So now when I orient my graph back to how it was originally, I'm going to grab a different color for my image, and I'm going to graph these coordinates. So 3, 2, here's V prime, 5, 3, here's K prime, 4, 5, this would be W prime, and then 2, 4. There's J prime. And because I can't draw straight lines, I'm going to get a ruler. But you should see this image starting to form that looks exactly like the image when we just turned our paper. Can't even draw a straight line with a ruler. So that's one way that we can think about this 90-degree counterclockwise rotation. This would also be the same as a 270-degree clockwise rotation. just so that you're aware. 270 clockwise, 90 degrees counterclockwise, negative 90 degrees. They're all representing that same 1/4 turn to the left. Before we make a rule for this and look at coordinates, I want to talk about another way you could consider this rotation. Since I am going 90 degrees counterclockwise, what we can do is actually look at the distance from the origin to each coordinate as a triangle, and then use that triangle to create our new point. So I'm going to use V as my example. So if I go and create, well, that's not gonna, let me get a highlighter, that'll work better. So I'm going to create a triangle that gets me to the coordinate V. So I've gone down 3 and over 2. Now I have to recreate this triangle, but I have to turn my triangle into this quadrant so that instead of this being a vertical distance, this is now a horizontal distance. So I would go sideways 3, and now instead of going side 2, I'm going to go up 2. And now this new triangle has helped me create V prime. And you can do that with every point. If turning your paper doesn't work for your brain, you can always use these triangle relationships to get each new coordinate. So if I was going to do that with K, I would have gone down 1, 2, 3, 4, 5, and over 3. So then instead of going down 5, over 3, I would go over 5, up 3. So now, as we did in translations and reflections, we're going to look at our coordinates and try to write a rule for this 90-degree counterclockwise turn. So V, K, W, and J. So currently V is at 2, -3. K is at 3, -5. W is at 5, -4. And J was at 4, -2. So now, if I'm looking at this in relationship to my prime coordinates, remember this is my original, and then I have to figure out how to relate X and Y over here into my new coordinate. Excuse me. So my rule for a 90-degree counterclockwise rotation is going to start like this, and I have to figure out what goes over here. Well, if you look at this original coordinate, it was 2, -3. They've switched positions over here. This was the Y value, this was the X value. And this has gone from a negative to a positive, so this Y is the opposite. And I'm going to check and see if that follows suit for every point. So these should flip, and the 5 needs to be the opposite, so it would be positive. And that is true for all of them. So for a 90-degree rotation, this is your rule. And that's 90 degrees counterclockwise. Next one we're going to look at is 180 degrees. I'm going to grab another Post-it note. So we're going to do the turning of the paper first, and then we'll look at it with triangles. With this, since it's 180 degrees, it could be 180 degrees clockwise or 180 degrees counterclockwise, because they will still end up at the same location. So if you look at what your image should look like, my new figure should land, if this is now my new coordinate grid, it should land mostly in quadrant 1 and partly in quadrant 4. So I'm going to write my new coordinates for this, and then we'll graph them. So I have V prime, K prime, Y prime, and J prime. So V prime will be 2, 4. K is at 0, 0. Y will be at 1, negative 1. And J prime will be at 4, 1. And again, just like the last time, I'm pretending that this is quadrant 1. So this is my positive x-axis. This is my positive y. So I'm going to take these and I'm going to rotate my picture back to the original and graph my image coordinates. So I have V at 2, 4. So this is, oh, that's an A. Upside down, that sure looked like a V. This is A prime. I'm so sorry. Okay, K prime is going to stay where it was, so this will also be K prime. Y prime is at 1, negative 1. And J prime is at 4, 1. So connecting these points, we should see all right, so here's my pre-image in black and my image in pink. I'm going to keep these points for later. Now if we think about doing this triangle, like we did in our last example, I'm going to just use A as an example. So I went down 4 and over 2. Now if I'm rotating it 90 degrees, I would put my triangle here. But because I'm doing 180 degrees, I have to take my triangle and go all the way up 2 turns. So this triangle, instead of going down 4, I have to switch it to now going the opposite way. So I'm going to go up 4, and I'm still going to go sideways 2, but instead of going to the left, I'm going to go to the right, and that will get me A prime. So now let's think about some coordinates here. So I have A, K, Y, and J. Here A is at negative 2, negative 4. K is still at 0, 0. J was at negative 4, negative 1, and Y was at negative 1, 1. So now comparing this to my image coordinates, in this case, they don't flip. They're still in the same place as they were before in my coordinate, but they've changed to the opposite sign. So -1 became +1, 1 became -1. These were both negative, they both became positive. So both of these are going to be the opposite of what they were before. So my rule for a 180-degree rotation is that X and Y stay in the same spot in my point, they just have the opposite sign. And then last but not least, here is a 90-degree clockwise. So same idea as our first example. However, it is the opposite direction. Now I'm going in the same way as a clock. So this image, my pre-image, when it becomes an image, should end up in quadrant 1 when I turn the page. So I'm going to take this, and again, I'm going to do the turning my paper first so we can visualize it. So now I'm going to picture this as quadrant 1. So let's write my image coordinates. So I have M prime, W prime, and V prime. So M prime will be at 5, 1. W prime will be at 4, 4. And V prime will be at 2, 2. So I'm going to pull these up. And I'm going to turn my page back to the original orientation. And graph these points. So here's 5, 1 for M prime. 4, 4 is here for W prime. And 2, 2 is here for V prime. And we will do the triangle method as well. And then we will write our rule. So I'm going to use M as my example. So for M, starting from the origin, I'm going to go up 5 and over 1. Since this is just a quarter turn, this up motion, my vertical motion will become horizontal, and my horizontal will become vertical. So I'm going to go sideways 5 and up 1. And if I wanted to draw a triangle out of these, I could. You could do the same thing for V and for W. These ones would be up 2 over 2. So this triangle, because it's an isosceles triangle, is going to put me in the same basic vicinity, just in quadrant 1. So now if we think about our coordinates, so our pre-image was at -2, 2 for V, was at -4, 4 for W, and it was at -1, 5 for M. And now looking at these in comparison to our pre-image points. Here's X, here's Y. Oh, I did them all out of order. Whoops. Let's look at M. Sorry. So M is at -1, 5, and M prime is at 5, 1. It's easier to see with M because these coordinates, these values are different. It's kind of hard to tell with with W and V since they're both 2s or 4s. So that's why we're going to look at M. So here's X and here's Y. So Y became my X value, X became my Y value, and then this is the opposite value itself. So for X, Y, it becomes Y negative X. So if you go back and look at this rule for 90 degrees clockwise in comparison to 90 degrees counterclockwise, they both flip, but if it's counterclockwise, Y becomes the opposite sign, and if it's clockwise, X will become the opposite sign. So we're going to go ahead and I'm going to switch back to the presentation and we'll look through some examples together, determining what rotation has happened. So I'm going from the black image here, GHE, to G prime, H prime, E prime. So I have gone from quadrant 4 to quadrant 3. So that is a quarter turn. So 180 degrees is out of the running here. I don't have a pen, so I'll just type it. So since I've gone a quarter turn, it automatically has to be 90 degrees. Since I went from here to here, thinking about if that's clockwise or counterclockwise, a clock turns in this direction, so this would be clockwise. Actually, I'm gonna cheat and I'm gonna copy paste, and then we'll change it as we need to. All right, so I'm going from E, V, whatever that letter is, I think it's a B. So I'm going from this triangle to this triangle down here. That is a 2 turn, so I know it's 180 degrees because it went a half turn around the clock. It doesn't matter if you put clockwise or counterclockwise because 180 degrees is the same thing either way. For this one, I'm doing black to blue again. It's a quarter turn because I went from mostly in quadrant 2 to mostly in quadrant 3. So that's 90 degrees. It's going in the opposite direction from a clock. So this would be a counterclockwise rotation. Oh, and that's all one word. And then last but not least, this is a half turn. So that would be 180 degrees. It does not matter if you put clockwise or counterclockwise because 180 is the same.